Greetings, ladies and gentlemen. For a country that is heavily dependent on fossil fuels for its energy needs, it is imperative that India focuses deeply on renewable resources, which will not just augment energy supply, but will also help India in mitigating climate change. Additionally, deployment of renewable energy in India will help advance economic development as well as improve the country's energy security. Union Minister of Road Transport and Highways, Mr. Nitin Gadkari, has been long emphasizing on the adoption of alternate fuels, which will become import substitutes, cost-effective, pollution-free, and indigenous, and in the long term, discourage the use of petrol or diesel as automotive fuel. In fact, by 2030, the government of India aims to reduce the country's carbon footprint by 30 to 35%. In meeting that target, one key strategy is to adopt bio-based and renewable fuels. The push for alternatives, however, has picked up steam in recent times, with the government setting a target of 20% blending of ethanol in petrol by 2025 and 5% blending of biodiesel in diesel by 2030. Given the government's focus on flex fuel engines and global discussions on alternatives to electric propulsion like biofuel, hydrogen, natural gas, and synthetic fuels, the Center for Auto Policy and Research, along with Mobility Outlook, designed and executed a four-part series titled Dialogues on Multi-Fuel Mobility in 2021-22, exploring and expanding on the feasibility of options like ethanol, hydrogen, the EV ecosystem, and gaseous fuels. In this season 2 of DoMFM, we propose to explore the deeper core issues related to the alternative fuel ecosystem and propulsion technologies of the future. In this season, we shall focus on the regulatory landscape, serviceability, end-of-life vehicles, and today we begin this season with a discussion around energy safety, assessing safety for alternate fuel technologies. The growth of the Indian automotive market over the next few years is likely to put tremendous pressure on India's energy requirements to fuel that growth. At the same time, this will also have an impact on the contribution of the transport sector towards carbon emissions. So the government's plan is to be done by increasing production of natural gas, promoting energy efficiency and conservation measures. Further, the government has given push on demand substitution by capitalizing untapped potential in alternative and renewable fuels, including biofuel. So ladies and gentlemen, in this session on energy safety, our panel of experts shall offer deeper insights into safety of alternate fuel technologies. And we're delighted to have with us today 4 prominent experts in their fields. Please join me in welcoming Dr. Amitabh Saran, CEO of Altigreen Propulsion Labs. He has over 29 years of experience with institutions like TCS, Philips, NASA, and Hewlett-Packard, and startups like Trivium and Bhasin. Throughout his career, he has focused on delivering innovative solutions to consumers based on contemporary and futuristic technologies. Passionate about clean energy and automobiles, Dr. Saran is the founder of Altigreen Propulsion Labs based in Bangalore, which develops high-efficiency electric mobility solutions in last-mile transport for India and emerging economies. He is a co-inventor of over 25 global patents. Dr. Saran, welcome. Our second guest today is Sethuramalingam Tyagarajan, General Manager, Power Engineering Research Center at Tata Motors. He heads 2 centers of competency groups, namely Gasoline Engine Combustion and Calibration Group, and Working Fluid Center of Competency. Mr. Tyagarajan has more than 30 years of experience in IC engine development for both commercial and passenger applications. Over the years, he has worked in various areas of IC engine development, like mechanical development, durability, performance development, emission, fuel efficiency improvements, etc. He also represents his company in SIAM and BIS forums. Welcome, Mr. Tyagarajan. Joining us from California is Dr. Lewis M. Fulton. He is the director of the Sustainable Transportation Energy Pathways within the Institute of Transportation Studies at the University of California, Davis. Dr. Fulton has worked internationally in transportation, energy, and environment analysis and policy development for over 25 years. Between 2007 and 2012, he was a senior specialist with the International Energy Agency in Paris and division head of energy technology policy during 2011 and 2012. He joined IEA in 2007 after working there originally from 1999 to 2005. During the 1990s, he worked at the US Department of Energy and taught at the Independent University of Bangladesh and the University of Maryland. Our final speaker today is Dr. Dinesh Bhasin, who served as a vice president at the Passenger Vehicles Division at Tata Motors and is a key member of CAPR. He is passionate about automobiles and has spent his entire career in the industry. He has the distinction of launching the Tata Motors service brand in 2013 and is the only after-sales service professional in India to have orchestrated and designed the service brand philosophy for two car companies, the second being Hyundai Motors India. His 35-year stint in the auto industry is an astute mix of work experience in sales, service, spare parts, dealer account management, and managing the world's largest workshop, Toyota Workshop, as a profit center head. Ms. Pamela Tikku, who was supposed to join us today, she is the office sitting director of the International Center for Automotive Technology. Unfortunately, she can't be with us today as she has been called for some important meetings at the ministry. For our participating delegates today, here's a reminder that you can actually interact with our panelists today by asking your questions. Please use the Q&A panel at the bottom of your screens to share your questions, and I shall take them up towards the end of the discussion today. So gentlemen, I would now like to invite our experts for their initial presentations. And I'd like to begin with Dr. Dinesh Bhasin. Dr. Bhasin, welcome once again, and over to you for your presentation.
Thank you, Dipanshu. Welcome everybody. Once again, good morning to my fellow panelists and the viewers. The topic of today, this discussion is largely for the alternate fuels. And in this alternate fuels, I would like to take you through the safety related issues on the electric vehicles. Whatever has happened in the last couple of years, that is something which has been happening at a very strong pace. I mean, very fast. Things have been happening very fast. In that process, sometimes we make some mistakes, sometimes we gain something also. In the EVs, for example, as it becomes more convenient to own a plug-in vehicle nowadays, the potential owners raise the question or have raised the question of safety. I'm talking particularly with reference to India. However, the lack of engine and flammable liquids make EVs, I would say, yeah, this is the first slide, the next one. Yes. Yes, thank you. Thank you.
Yeah.
Few words about how did it all start, or maybe some introductory words. See, India is a unique automobile market with 84% of vehicles, rather 80 plus. Sometimes the figures are between 80 to 84. The vehicles sold are two-wheelers and three-wheelers out of the total volume. We imported $112 billion worth of crude oil in fiscal year 19, equivalent to roughly at that time 4% of the country's GDP. I have chosen fiscal year 19 because last 2 years have been little buoyant and I mean because of the COVID. So these figures represent slightly better picture. It may be 4%, maybe 5% today. While electric vehicles may not immediately address the vehicle population, they are certainly a key enabling step towards ultimate vision of clean energy, which our government is actively pursuing, and which is also slightly a part of our discussions today also. Just to know, maybe we all know it, but many of the viewers, some of them may be interested to know, key components of an EV battery is 35%. This is by number of components, is battery. Of a car. 25% is taken by drivetrain, and body and chassis 20%, systems, equipment, and other parts is 20%. So battery, as you see, is as high as in terms of number of components, 35%. Close to $30 billion have been invented in the lithium-ion battery, and a very important part of EVs. Lithium-ion is the most talked about battery nowadays, though some alternatives are also being explored. So the industry capacity for the production has been increased from zero around 12 years ago to now 300 gigawatts in 2020. And similarly, the battery prices have also fallen. The figures are mentioned here. They are expected to fall further in the next 2-3 years. Electrification will cause a major shift in the entire automotive supply chain. This is something I believe, because as you know, the whole ICE engine, internal combustion engines, petrol and diesel engines are being replaced by the battery. So which I mentioned is almost 35%. So what will happen to the guys who have been manufacturing engines and components? What I feel, while the direction is correct, speed and safety need to be picked up. Next slide, please. Thank you. So here is a little snapshot of the mix of the fuel mix of the Indian passenger vehicle, primarily dominated by petrol and diesel. But what you can see, especially in the last 2 or 3 years, we can call it a BS6, Bharat Stage 6 era, which is also equivalent to something like Euro 6 era. No, yes, please. So we have slowly moved to around 1.1%. The battery vehicles, the EVs, are roughly 1 odd percentage still of the total number of vehicles. That's the only message we want to convey through this slide. Next slide, please. And the volumes in terms of the EVs has roughly reached 4,500 per month. Slowly from roughly 4 years ago, around 20, 30 or 40. So that's a small progress which this country has made. Next, please. Okay, in terms of the rise of the percentage of the EVs, quarter-wise, for the last 4 years, as we can see, we have taken 5 odd years or 4 odd years to reach 1% from less than 0.02 or 0.03% 5 years ago. So very slow progress. Next, please. If you have a look, there are few manufacturers who have taken a big lead in this. One of them is, for example, Tata Motors. Tata Motors, you can see from the chart, the fourth bar, 1, 2, 3, 4, the fourth bar, the mix of the electric vehicles and the others is a very healthy figure of 7%. This is based on the first half of 2022. Followed by another company, MG Motors in India. This is for the petrol vehicles we can see. While for the diesel heavy vehicles, I mean the other manufacturers who are mentioned at the bottom, we find that the progress has been rather very slow. Once again, progress related to only the contribution to the by the EV vehicles. Next slide, please. Coming to, I would say, a little more interesting topic, as I mentioned at the beginning, 80 to 84% is the volume contributed by the two-wheelers. Even though India is the largest two-wheeler manufacturer globally, for fires in EV, particularly these two-wheelers, the industry still needs, I believe, to do a lot as a part of learning graph. Not only in India, you know, this phenomena of this fire and safety issues has been witnessed earlier in developed countries like Europe and China also. So going through the safety test cycles and thereafter mass production takes place. So many precautions need to be taken by the 2- and 3-wheeler manufacturers. Next, please. In terms of the numbers for two-wheelers, I've tried to capture, give a comparison of the last 2 years. If you can see the 1, 2, 3, the third column, the bottommost figure, 231,000. 231,000 of the electric two-wheelers were produced and sold by India in the fiscal year 2022. By fiscal year 22 means April of 21 to March of 2022. Compared to that, have a look at the bottom of the 1, 2, 3, fourth column under fiscal year 2021. That was hardly 41,000, healthy, roughly 500%, I mean exact 463% jump for the two-wheelers. This is what is a good thing on one side. I would say this is very fast. The growth is very fast. In the process, I do not know whether we have adhered to all the processes. And then off late, we have been seeing some cases of fire on the road and other things. Next slide, please. So not a slide which I wanted to show, but just this has been happening off late and has been a And this is where I got prompted a couple of months ago to do some studies on this. Next slide, please. I don't have much. The topic, in fact, is pretty large. I don't have much to contribute on this except some text, which I'm just going to read out for you. According to me, the training of the field forces, the network people, has to be done on priority, because they are the people who have been handling ICE, internal combustion engines earlier, and now they have to handle the EVs. The place where I stay have got at least 3 or 4 EVs, I find. I mean, they have installed a charging station, but then even the customers, I mean, since I happen from the industry, I happen to have spoken to those customers. I find there's a lot of need to change to train the network, including the customers. Secondly, the adherence to the safety norms or the SOPs stipulated by the regulatory and internal systems for the battery chemistry and also for the whole ecosystem. This is important. I mean, we must adhere to the SOPs stipulated. Another interesting thing which I have observed is the EV parts scrappage SOPs. Of course, India has come up with a scrappage policy. The EV part scrappage is one of the very important things. What will happen to these motors, these batteries, after they complete their end of the life period? Similarly, the vehicle scrappage policy implementation in later period for entire EVs has to be looked into. Recycling of lithium-ion battery is something very important, and we all know, as we all know, it comes from the mining of cobalt, lithium, graphite is a very important metal. Although China is not known for mining, but then most of it comes from China. So recycling of lithium-ion battery is something which is very important. One of the key challenges, according to me. They pose some safety hazards. Similarly, challenges posed by connected vehicles are highly dependent on the power supply, as we all know, battery. Any malfunction by any part can lead to safety concerns. 35%, as I mentioned, by components, the battery components. So more electricity. If you go to the last line, I would also say the compartment becomes a rather high voltage one. So like what happens in ICE vehicles, you know, unfortunately, when vehicle catches a fire on the highway, so there's a roadside assistance team which comes with a conventional cutting tools that take the, people and something out. I wonder, technically speaking, if the battery does not get auto cut off, whole car compartment being a little high voltage area, what would happen in case there was some malfunction? Next slide, please. So this is just one example. I mean, you can see a lot of such things we'll have to see. This is the all EV scrap, EV related scrap, I would say. Where will this go? How will we dispose of? Next, please. So whatever little research, not research, I'll say studies I have done, I find if we can do something in the fall for the following couple of things, probably we stand to, the industry will gain a little bit. One is the blockchain connectivity, especially for the two-wheelers, including cloud integration. I do not know whether I have time, but if I may like to say the advantages, opportunities of blockchain connectivities, secure ownership, peer-to-peer vehicle sharing, peer-to-peer energy trading also, data monetization, and things like that. A lot of things which we can do. Little advanced topic, but then yes, some people have started working on that. This is one of my recommendations. Mass customer education, I just mentioned one of them, one example. And large-scale distribution. Distribution in India, we also call network. Distribution network development for battery charging or the battery swapping infrastructure. A lot of different things being carried out. A lot of new companies are being formed for battery swapping. I think there has to be some norms, some standards. Adherence to regulatory guidelines and internal SOPs. Similarly, intra-industry collaborative approach for optimization. There is a possibility of some, I would say, we should not go the ICE way. Some collaboration is required amongst the suppliers also. If I take an example from outside India, I don't know much of thing is happening in India. There's a company called Diamond Motorcycles. I mean, they're collaborated with Otaco. They have formed a partnership for Otaco, an ICE two-wheeler market leader in Colombia, something like that. There's a company, after we all know Harley Davidson. They have collaborating with something called Kimco, KYM company, investing also some $100 million in Harley Davidson's Livewire brand kind of thing. Just one example, two examples come to my mind. Such things are required to be done in India also. One company alone, gentlemen, cannot do on its own. Technological development, the EV space is another recommendation from my side. Government also needs to pitch in and give its all support and the understanding of the industry hiccups. Each industry has got some hiccups in the beginning. So would be this also. Consolidation. Too many mushroom growth players, I mean, need to take customer centricity and their safety seriously. I do not know whether all of them will survive. Before I go to the next slide, the last slide, one or two more observations. With the entry barriers in electric 2 and 3 wheelers being low, I mentioned about the mushroom growth. Components being less, there are less components in EVs. Initial investments are also low. We find many people jumping into it. We see a number of manufacturers jumping into it, thus skipping the SOPs in a race to launch their EVs faster. However, the increasing fire incidents in EVs, according to me, should not be seen as a deterrent to the EV growth. I mean, EV has to come up. I say it should rather be an opportunity for increasing the competencies and stringent testing standards. One caution, according to me, which I need to point out here, is that the EV industry should not go the way ICE one did, which I just mentioned about the collaborative approach. I try to give some examples also. We probably should also create a repository of the learnings of the solution to the fire cases so that everyone benefits faster. Individual companies on their part can also advance their recalls program, if at all, to prevent more cases. Next slide, please. Which brings me to conclusion. Of course, thanks a lot for patient hearing, ladies and gentlemen. I have pointed out just some key pointers towards safety of EVs on which a lot of work is going on. However, I feel like asking sometimes myself if EVs are the best option for replacing ICE engines or vehicles, or do we have some other alternatives? Thank you very much once again, everybody.
Thank you, Dr. Bhasin, for your presentation. I do have some questions for you, but we'll come to that later. I'd now like to invite Dr. Amitabh Saran. Dr. Saran, the screen is all yours.
Thank you. Thank you, Dipanshu. Hello, everyone. Good morning. Thank you so much for sparing the time to hear us out. I really like this topic of safety, and I think Dr. Bhasin has given a very, very good introduction on all the various aspects, that we should be careful about. I belong to that sector of the industry which Dr. Bhasin mentioned as one that has been mushrooming really fast, the two-wheeler and three-wheeler segment. Altigreen, my company, focuses on building cargo three-wheelers. I think the important thing for me is not necessarily on the mushrooming side as much as it is about maintaining the SOPs and the safety standards, both internal and external. I think it's very, very important to see this in a larger context. If you see ICE vehicles, if I remember correctly, back in 1923, when ICE was just starting, there were about 1,800 manufacturers in the US alone who were manufacturing vehicles based on ICE engines. Whenever new technology comes in, a lot of startups will jump in. How many will survive? How many will take it easy? How many will be able to get there? I think is left to the individual companies to do the right things and to create a good structured organization. Safety is paramount, and hence those are the companies, those are the organizations that survive. This is not to say that ICE vehicles don't catch fire. This is not to say that that is a completely well-defined everyone's following very good processes. It's not about us versus them. It's not about EV versus anything else. I think it's more got to do with finding the right components and utilizing them in the context of your use case. I think to me, those are the defining things. Very simple thing, for example, take an electric rickshaw. I think most people don't count them as part of an EV network that is getting established in the country. There are 2 million of them that have mushroomed over the last 5 or 6 or 7 years. They also use a charging infrastructure. There are stories that most of them are stealing power. I don't believe that that is the case. In any case, a large part of northern India has a customer base, is utilizing them. There are about 400 odd manufacturers who are approved in various homologation agencies across the country. We don't operate in the L3 space, but I'm saying if you were to take an e-rickshaw, I personally feel that safety is kind of a relative parameter. An e-rickshaw, for example, is very, very safe if you're driving at 10, 15, 20 kilometers an hour. Try to drive it at 60 kilometers an hour if you were able to. It would not be safe. So in every context of use and the purpose for which it is built, I think we have to see that from a perspective of components. Case in point, for example, cells. The inherent problem is not the cell. The problem is a well-engineered product on the basis of the specification of the cell that a manufacturer has shared. Quite a few times we overlook that. A cell is a cell is a cell, which is not the case. A cell is a cell, of course, but it can't be used in the context. A 25-degree cell cannot be used in the context of 45-degree Rajasthan or Delhi heat. You have to build systems and processes around it to ensure that it remains at that temperature. For example, a cell characteristic might be different in terms of the extremes when it is 100% versus when it is 10%. I think a lot of those kinds of things have to be considered when you are coming up with a solution. It has to be driven by use case. We cannot have, an e-rickshaw, for example, is built for a specific use case. You can't take that and say that it has to pass crash tests. It will not be able to do that. But it serves a specific purpose. It is not to say that e-rickshaw driving at 10, 15 kilometers an hour is not safe. It is. So coming back to the context of India, I think the good part in all of this is that fossil fuels have survived in India for the last 100 years. They've done a magnificent job. I personally feel that electric drivetrains will definitely be the future, whether they're powered through lithium batteries or aluminum batteries or sodium batteries or nuclear fission and fusion, for all I know. I think the future will be electric in terms of drivetrains, just because it is making the system a lot more efficient. We're moving from a 25% efficiency in ICE engines to a 90% efficiency in electric motors. Obviously, through the value chain, there are differences. But as we move to more renewable sources of energy, I think well-to-wheel is the efficiency is improving dramatically. In the context of that, for everything, I think it's not just at the battery level, but when we choose a suspension or the right kind of wheel or the body structure, air drag, whatever we are looking at, it has to be in the context of the use case. It has to be in the context of what we are building, and then make sure that we're building a very safe vehicle. I think we cannot overlook those kinds of things. Also, we cannot say, sometimes I've noticed, when companies mushroom, they say, well, they try it out in a certain geography, in a certain regional geography of the country. And then as they expand, they forget that they never made it for, let's say, a high temperature area or a high altitude area or something like that, which is where these kinds of accidents start happening. India is a country where abuse is very common in our vehicles. That's the nature of the beast. We have to ensure that all the vehicles that we build are built for abuse. ICE vehicles have done magnificently well under abuse. And hence, that's the expectation that has now been set. ideal in the commercial vehicle space, and hence that's the expectation that has been set in that space. Passenger vehicles and personal vehicles come in a very different category as far as I'm concerned. I think it will take time for them to get electrified. Commercial vehicles will probably have an uptake faster, and hence the burden of ensuring that we create the right kinds of systems, processes, components to a certain extent will lie on the commercial vehicle industry, possibly two-wheelers, three-wheelers, small commercial four-wheelers, because people are going to look up to them and kind of say that, okay, did it create a stable product? Is it working fine? Are things okay? Are they following safety standards? And that kind of starts building a certain kind of confidence in the industry. So I'll stop at that. I think Dr. Bhasin said some very good things. I was just setting the context on the lower end of the pyramid to say that as long as we're focusing on the use case and building to that use case and building it in a larger context of abuse, of environmental abuse, of driving abuse, of all kinds of things, road infrastructure, all those kinds of things. If we build vehicles to that, I'm sure we can make them very, 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 very stable and very, very safe. Thank you.
Thank you. Thank you, Dr. Saran, for offering your perspective on the aspect of safety and suggesting that we must and we should build vehicles for particular use cases, right? I would come back to you with questions a little later. At this point, I would like to invite Mr. Sethuramalingam Tyagarajan from Tata Motors. Mr. Tyagarajan, over to you for your presentation.
Yeah, thank you, Depang, for having me here. And a warm good morning to all other panelists and delegates. And good evening to Dr. Fulton. So today I'll be sharing my views on the product development challenges and dilemma faced by OEMs with respect to the current focus on alternate fuels. Allow me a moment to get my slide on. Yeah, you're able to see my screen?
Yes, it is visible. Thank you.
Yeah, thank you. I'm going to share a few slides to build on the background before I move on to my main theme. So starting with energy security, it lies at the heart of national security, environmental security, and economic security. Any country's national security directly depends on energy supply, and meeting the energy demands directly impacts the economy. The key focus of energy security is less dependence on fossil fuels with increase in share of renewable clean resources. There is no surprise that today so much focus and attention is given on alternate fuels by the entire world. It is well understood and documented that going at this pace, we would finish off all the crude oil resource by the next 45 to 50 years. Hence the urgency in switching to alternate fuels, as right now, it's impossible to imagine the fate of human race without fossil fuels. The concerns on environmental pollution is a driving force to look at carbon neutral renewable solutions. So to achieve these targets, as a country, we are exploring several options of alternate fuels, namely ethanol, methanol, DME, biodiesel, hydrogen, HCNG, synthetic e-fuels, and of course, the hero of the pack, the electric vehicles. Each of these options presents own pros and cons and is a constant topic of discussion among all stakeholders. Towards this, we must appreciate the efforts made by the government in promoting and facilitating the progress in this direction. Different ministries have been pushing for different alternate fuels through various policies, notification, and announcements, be it the Ministry of Road Transport and Highways, Ministry of Petroleum and Natural Gas, Ministry of Heavy Industries, Niti Aayog, etc. So what does it mean for the automobile industry or the OEM? Let's revisit the challenging times when we migrated from BS4 to Euro 4. Sorry, from BS4 to BS6. Europe migrated from Euro 4 to Euro 5 and then to Euro 6, taking 7 to 9 years. In contrast, the Indian auto industry was tasked to develop first-time right BS6 products within the time frame of 3 to 4 years, which required Herculean efforts from all stakeholders. However, the advantage here was the regulation requirements were well defined, and also the focus was only on the conventional fuels. Whereas now, the biggest difference is we are exploring the use of multi-fuels like ethanol, methanol, biodiesel, hydrogen, EV, etc. simultaneously. So the regulatory frameworks are also evolving. Facilities for fuel handling, storage, ensuring fuel availability, safety concerns, all are under discussions. There is no clarity as to where the OEMs have to place their bets and deploy the resource and efforts. Should the OEM pick one of these and focus on it, or simultaneously work on all of them? Because the current scenario is so dynamic that no one is sure how the fuel landscape will pan out. Added to this, there is a need to reskill the existing manpower and also redeploy resources strategically. To further emphasize on the challenges and dilemma faced with OEM, let me take an example of steps needed for development with any one alternate fuel. For example, ethanol flex fuel. We first need to ensure the hardware compatibility with the subject fuel. Then the performance, combustion, emission development has to be done to ensure that we meet the regulatory requirement and the customer needs. Third is the EMS ECU calibration, which involves hundreds of calibration maps and thousands of variables. When we look at hardware changes, all the engine components and fuel system parts which come in contact with the fuel need to be identified. Then the suitable materials need to be developed to ensure compatibility. And then we need to validate it. Some example of key components needing investigation, which are well known, are pistons, rings, cylinder head, valves and valve seats, fuel injector, fuel pump and hoses. Even the fuel tank, depending upon the fuel, has to be completely redesigned. Apart from the hardware changes, we need to optimize the combustion with the given fuel so that there is no significant loss in performance parameters like power, torque, SFC. It also needs to be ensured that the vehicle emissions are well within the regulatory requirements. The EMS calibration is a process involving sequential function calibration, moving from one function to another, starting with air charge, engine start and idle, the transient drivability, followed by emission, OBD, and finally RDE and IUPR. So these activities involve calibration of more than 10,000 variables and 3,500 maps. This also, of course, involves building of adequate number of prototypes, requires facilities like chassis dynamometer, engine dynamometer, climatic chamber, and activities like validation on road. Test trips in extreme condition like summer, winter, and altitude test trips needs to be completed, requiring a total development timeline of around 15 to 18 months. Things become more complicated when it comes to flex fuel vehicles. Example, flex fuel E20 to E85. We need to have calibration done at E20, at E85, and also some intermediate blends in between. This means all the efforts and resource requirement are increasing multifold. Even the number of prototypes that need to be validated increases. Other challenges like logistics, safety in fuel handling, fuel availability have to be addressed simultaneously. This would lead to doubling the total timeline to around 36 to 48 months. This is for focus on just one type of fuel. Imagine if the OEM has to initiate research on multiple fuels simultaneously, which I talked about earlier. Then the type of resource and budget requirement would be mind-boggling. It's really overwhelming. So in conclusion, it's clear that with fossil fuels getting depleted and concerns in environment pollution, the focus on alternate renewable fuels with clean solution is need of the hour. In the past, industry has always supported various government initiatives and risen to the challenges. But now, with multiple fuel options being discussed, one after another, there's no clarity on where to place one's bets. embarking on research with multiple alternate fuels, in addition to upcoming norms with conventional fuels, pose a big challenge to the industry. Development of fuel specification, regulatory norms, logistics for fuel availability, safety requirements have to be taken up on board footing. Manpower reskilling is another important focus area. As a parting comment, I would like to emphasize that it's our collective responsibility to ensure we leave a better world for the future generation. Thank you.
Thank you. Thank you very much, Sethu, for sharing your perspectives, particularly from a product development point of view for an OEM. Our final speaker today is Dr. Lewis M. Fulton. Dr. Fulton, over to you for your comments.
Thank you very much. And it's a pleasure to be joining all of you. And it was great to hear all of your thoughts on the topic that helped me kind of understand where our discussion's going. And I think you've covered a lot of ground here. I mean, quite a bit talking about electric vehicles and some of the issues both for four-wheel and also two- and three-wheel vehicles and batteries that we have to address. But then also hearing about all these other kinds of options, liquid fuel types of options, and some of the challenges, at least from the vehicle side, if you want to have flex fuel and be able to handle different kinds of fuels. So no matter what we do, there are going to be different challenges. Some of them are safety, directly related to operating the vehicle. And maybe in my remarks, I'll broaden out the idea of safety to any kind of negative impacts that we want to be paying attention to. So this could also mean the climate impacts, the air pollution impacts, which of course there's really a safety part to that, how the public is affected by air pollution, and even land use. I think when it comes especially to fuels like biofuels, if we want to use biofuels in large quantities, especially across multiple types of vehicles, multiple countries, and then even some biofuels for transportation and some bioenergy for other sectors, it adds up to potentially very large quantities that have big implications for the planet. So my idea of safety covers all kinds of things, but I'll just remark on a few specifics that I think are hopefully helpful. I do think that we are presented with three pretty distinct kinds of options for trying to decarbonize and move to more sustainable transportation. And that is the electrification of vehicles using substitute fuels that are more or less compatible with today's vehicles. So these are mostly liquid options, and then gaseous fuels. So that's a third very distinct thing. And in India, you do have a lot of natural gas vehicles. It's been very successful. I think one of the more successful countries in the world to adopt natural gas vehicles. And of course, we see hydrogen vehicles coming. Hydrogen fuel cell vehicles could be hydrogen internal combustion engine vehicles as well. But I think the future for hydrogen is probably with fuel cell vehicles, both because they're very efficient and because you would then have a zero emission, zero tailpipe. There's no tailpipe. It's actually, there is a tailpipe that produces water vapor, but that's it. So they're like electric vehicles in that you've eliminated the vehicle pollutant and carbon emissions from the vehicle. But they have completely different requirements. They have different kinds of infrastructure that you need. The supply chain implications of these different technologies are very different. And the refueling or recharging infrastructure implications are very different. So I think this is the challenge that all countries are facing right now, is how do we decide which path we go down? And I think ultimately we'll probably go down multiple paths, at least for a while, and maybe some things will sort themselves out, or maybe we'll end up with multiple systems that coexist. And I think that for at least, let's say in the United States, I won't speak for India, but I think in the United States, it's beginning to feel like electric is going to eventually dominate the light duty sector. So 2, 3, 4-wheelers, we don't have a lot of 3-wheelers, but 2 and 4-wheelers are going to be electric. They might be plug-in hybrid, but eventually we're going to eventually eliminate internal combustion. For trucks, I think it's going to take longer, but also I think hydrogen is a very interesting option. For trucking, you can get a longer range from that. And then you have a question of whether it's gaseous hydrogen or liquid, cryogenic liquid hydrogen, which I'm certain has important implications for the safety of those kinds of vehicles. I will mention that for fuel cell cars, the models that are in service nowadays, like the Toyota Prius and Hyundai Kona and a few like that, very, very impressive safety records and safety ratings. The fact that there's a compressed hydrogen on board doesn't seem to pose a big problem in crash tests. So that's good news right there. I also think the electric vehicles have been looking pretty good too in crash tests. And, you know, across the board now, vehicles are getting better and better in these kinds of crash test situations. And, you know, it's hard to tell, I think, whether there's going to be a big advantage one way or another. But we should remember that we do have a lot of automobile and truck fires with gasoline and diesel every year, so they're not perfect either. So I think that one of the more interesting parts of this is for the kinds of vehicles that continue to use liquid fuel. So some kinds of trucks will for quite a while, maybe especially long-haul trucking. And then I think we're also going to see liquid fuels for shipping and aircraft for a very long time. Biofuels, we might see some ethanol. I know India's at, I think, 10% ethanol right now and probably going to increase. We have about 15% ethanol, close to 15% in the United States. We're actually rising more rapidly now with biodiesel, or renewable diesel, as we call it, in the United States. In California, the diesel pool for diesel plus bio-based diesel, we're up to 25% of that pool is now is renewable diesel. So that's really getting to be important. So that is happening. And I think on this liquid fuel side, we've got those biofuels. They tend to be very clean. They're going to be very helpful in reducing a range of pollutant emissions, along with, you know, continuing to ramp up the emission standards. They are, if it's ethanol, it's not a toxic fuel, it's not a toxic blend, or if it's a renewable diesel, it's not a toxic blend, excuse me. But there are some other options like methanol. Ammonia is an interesting option, especially because it can be a very good hydrogen carrier. But those two chemicals are toxic, and you have to be careful how you handle them and how you use them. So I think there are inherently some safety issues with both methanol and ammonia, but they are probably going to play some kind of a role in our transportation systems in the coming years. And then the last one I'll mention is kind of a long-range aspirational option, but could end up being important, which you might call e-fuels, or sometimes you hear power to liquids, but it's the idea of producing long-chain hydrocarbon fuels from electricity, and then you capture CO2 from the atmosphere, or you obtain CO2 through some kind of a process to produce your liquid fuels. So it has the potential to be zero net carbon, very, very clean fuel. And so it's super, and then also no land use implications. You're not having to grow it anywhere. The problem there is it's very expensive right now. And so I think we need to keep working. We need to do a lot of research on that option, but also building up scale, getting the projects going, getting some tests. And I don't think it's a big problem for tests. I think the vehicles are going to be fine on those kind of fuels. It's more about getting enough projects that you get some scale to produce those kind of fuels and begin to bring the costs down. I think it's going to take 10 to 20 years to do that, but I think those fuels may turn out to be very important to help us, especially with long-range trucking, shipping, and aircraft. So we've got this wide range of options. I think basically we can move toward a fairly safe and secure system across the board. But everything we do, we have to be thinking about the safety requirements, the testing that we do, how the public might be exposed to certain kinds of chemicals and things like that. And but I think we can handle those aspects, and we're going to have to just figure out what's the best combination of technologies and fuels to get us to a sustainable future. Thank you.
Thank you, Dr. Fulton, for giving us an all-round perspective on different kinds of opportunities that we have, and to ensure that we lead towards a sustainable future. We will now start get into a Q&A, a discussion among the panelists. And Mr. Tyagarajan, I have my first question for you. You did mention that in the EMS issue calibration, more than 10,000 variables and about 3,500 odd maps need to be calibrated. So when we shift from conventional fuel to alternate fuel for a given engine, does all these variables need to be recalibrated right from scratch, or only some percentage of it needs to be calibrated and the rest can be carried over?
Yeah, Deepang, that's a good question. Actually, it depends upon the type of engine level changes we need to make to move from the original fuel to the new fuel. For example, if we consider ethanol, okay, and we can look at two scenarios. One, you can talk about lower blend of ethanol. So maybe we can get away by carrying forward the same engine hardware with minor tweaking in the calibration of some maps and variables. But if you talk about higher blends, for example, E85, then we need to compulsorily redesign the engine, enhance the component ratio to take advantage of fuel properties, and thereby improve the combustion efficiency. Mm-hmm. So in the case, the entire calibration architecture has to be revisited. So it actually depends upon where you are and what is the fuel adopting and what is the percentage of fuel you're adopting. That's put the quantum of work on the table. Okay.
Dr. Saran, you of course, like I said, in the commercial vehicle space, when you entered this space, what were some of the key considerations that you had to keep in mind to ensure that the products are not just robust and stable, but also safe from all internal and external factors?
Yeah, like I said, for us, we had a very good precedent, diesel vehicles. I operate in the L5 category of three-wheelers now. We are looking at other products, including adding more wheels to it. But I think from our perspective, we did a lot of R&D on ensuring that electric vehicles and the drivetrains, the components that make the electric vehicles stable, are the ones that we do our innovations. We have 26 global patents that have been granted to us on these technologies. Once again, the idea of these patents is not so much to talk about, creating a moat around ourselves, but to say that for the conditions and the environment of India and the use cases here, there is a growing need for countries and other players to innovate. A lot of these innovations are with respect to safety. I've always maintained that the environment here is very, very difficult. Driving behaviors are very different. Overloading is very common, especially in commercial vehicles. Road infrastructure is not very good. There's waterlogging, there's dust, potholes, pebbles, enough pictures floating around in WhatsApp for you to be able to see the reality. So when you design a new technology vehicle, it has to be at least as good as the one that it is going to replace. In our case, it is diesel, and hence from a safety standpoint, whether it's the motor, it has to be environmentally sealed. There is no question about water being able to enter. It should be in a position to take a 30, 32, 25 G shock every time an overloaded vehicle goes into a pothole. Similar things on batteries. If the ambient temperature in Delhi or North India for 4 months a year is going to be above 40 degrees, if the ambient is above 40, you can't expect that, forced air cooling will be enough if your cells are going to be at 25 or 35 degrees, the cells that you choose. Everything we realized has to be over-designed. so that you get to a certain standard of use case. Once that is done, then you start optimizing. Let's not start with the basic minimum and then say, okay, it can be stretched, because India is a very different beast. You have to innovate for India, and that's why it took us 9 years to get here. There is no shortcut. I have to say this, and I completely agree with Dr. Bhasin. There's no harm in mushrooming, but at the same time, be careful about the safety standards in each of these components, electronics, motors, including the wire harness. I mean, people don't think too much about it, but there is a lot of concern there, including EMI, EMC, that happens because of the way you use harnesses and all that. So, lots has to be done, but it is all doable.
Right. You did also stress on the importance of finding the right components and also understanding the specific characteristics and the performance matrix of the cells that one uses. But could you also give us an insight into the kind of work that you have done towards the battery management system that you have in your products, Dr. Saran? Help us understand, because you've talked about ambient temperatures and the diverse conditions across the country. How have you gone about optimizing it?
Once again, I mean, the good part is that so there are two kinds of issues that I've noticed, in most products. One is not a very good understanding of the use case itself, whether it is environmental, whether it is about driving, once you have that understanding, you will build to it. I think a lot of people don't realize the kind of shock that, components go through when an overloaded vehicle falls into a pothole, when the suspensions are not supposed to take that kind of load, whatever. I think if you instrument your vehicle properly and you look at each and every category of, the components that you're using, in our case, for example, like I said, over design is absolutely imperative in our country because there is abuse. And, I spent a lot of time with, delivery agents and drivers, and it would not be right for me to teach them how to run their business. They figured it out. You can't convince them, boss, why are you overloading? Instead, you should do 2 trips. It is better and more efficient for you. No, boss. I'm not here to teach them their business. They've understood. They figured out that this is the way things work for them, and they will do that. I think from our perspective, the BMS choice of cells was very, very important. Now India will start in the next couple of years. Hopefully, India will start producing very good cells that are going to be key for, a lot of transformation that happens in the EV space. But until then, we do import cells. All cell manufacturers will share very, very detailed, specification sheets. It is important. The onus lies on us, to evaluate those sheets, to figure out how the impedance is changing, to evaluate how these cells are performing on the limits, on temperatures. It's all given there. It's for you to overlook and say, ki, nahi yaar, I need to make a vehicle under 2 lakh rupees. So, chalega yaar, abhi to ye lene ka. That is where challenges start happening. Then when you design a pack, for example, the placement of the BMS, how it's placed, what all it is taking care of, how many thermal sensors do you have that you're tracking on a constant basis, currents, voltages, the sensitivity levels of each of these. It's all there, Dipanshu. It's not that, it's rocket science. I used to work for NASA. I can figure rocket science also, but I'm saying that it is not rocket science. It's just careful deliberation, following process, and ensuring that you're looking at each of those things. You can't overlook one or the other, because this is, I have to say, this is unlike fossil fuel vehicles, where again, it's not that, they are any easier, but these are more sensitive to, all kinds of abuse case. So you have to be a lot more sensitive about each of those.
So there is clearly no cutting corners when it comes to handling such kind of power options, right? Dr. Bhasin, considering your experience in the past, one question specific to you. From a serviceability perspective, how are EVs different from, let's say, conventional ICE, and what safeguards must one ensure while servicing electric vehicles?
So we all would know, not only we, even a non-technical guy would know who drives a vehicle. Let's take example of cars. When he takes it for service, he knows his oil, the engine oil will be replaced, the filter will be replaced, other filters also, air filter, fuel filter, and he would be charged for that. His suspension would be overall, steering system would be looked into, all nuts and bolts, etc. would be checked. Now, as I mentioned earlier in my presentation, that here the only change, broadly speaking, the other changes also, like Sethu mentioned about the calibration of the EMUs, ECUs and other things. Of course, that is required. But the only broad change is the engine. So when you remove the engine from the service point of view, there's no service required by and large, except the battery charging. Battery would be continuously charged while the vehicle is running. So you eliminate the changes of the engine oil, gearbox oil, some filters and other things. I have not mentioned, because that was not a part of the discussion, but just to answer your, and maybe to substantiate what I'm saying, the servicing cost is likely to come down. The need for the vehicles to come, the frequency of the vehicles to come to the workshop will come down. The other parts, for example, as I mentioned, the suspension, steering, even electrical system, I would say that switching on the headlamps and the things, would by and large remain the same. And they generally don't require any service. So, and that's what I partially touched upon in my presentation, also brings to the point of training the manpower. We would have seen as a customer, when you go to the workshop, we are normally asked, today the electrician has not come. Now there is no concept as far as this Japanese technology, and these people believe, when I started working in a Japanese company 35 years ago, that the electrician and technician are the same thing. Technician means the guy who changes the oil, electrician the guy who repairs the alternator and other things at that time. The role of, for example, since the electronics goes up in this vehicle a lot, so the role of retraining the people, those mechanics, you have to live with those mechanics. Those mechanics have been there in thousands, probably in 100,000, I would say. You can't ask them suddenly to leave, so they have to be retrained. So there were a lot of changes related to service, which, of course, I'm glad today you have asked this question. I'm also glad that this question is being discussed with a wider audience. This is one of the major things which is coming up. And the distributors, the dealers, OEMs, of course, may be giving it a thought. Not many set of people are giving it a thought. This is very important. I gave an example of three customers of EVs who stay in my building. And they have started asking many questions. I wrote on EVs somewhere else also. I got a lot of queries from normal customers. So customers, as well as the dealer manpower, as well as even the sales guys. Kitna deti hai in a mileage, as we get asked this question, how much this vehicle gives. People are very curious of the range. This range anxiety is one of the biggest questions being raised for the electric vehicles. So there will be a lot of changes for the network, the workshops and other things also. Right.
Dr. Bhasin, you've emphasized on a aspect which is, again, extremely critical, which is about skilled manpower, right? And so I'm going to take this question to Mr. Tyag. You spoke about the requirement of manpower reskilling as well. Now, what exactly needs to be done for the same? Should it be done at the academic institution level or at the job? Or do you think, there has to be more sort of structured approach to skilling manpower, particularly for the EV domain?
Yeah. See, the approach needs to be on multiple fronts. One option is to conduct company-specific sessions with external experts. Yeah. Other is to attend seminars and webinars like the one what we are doing now. And of course, there is also an option to collaborate with academia to formulate tailor-made courses which is there. So also we could take up some research project on these topics in collaboration with other stakeholders. So we get some real-life hands-on experience also. So even at CIM level, we are collaborating with agencies from Brazil and US to get some more input on this topic. So I feel a combination of all this has to be done to get us there. So it's not
Right.
one part, but it has to be a combined part of all things, whatever is possible.
For sure. Dr. Saran, I'll take the same question to you. I mean, you've given us a sense of... yes, Dr. Bhasin,
sorry,
please go ahead.
that's very interesting question which you asked. And in fact, I should have also partly covered. Just give me 30 or 40 more seconds.
Absolutely.
That also means that the school, colleges, universities, ITIs, etc. You touched upon this, and it's very valid. Also have to revisit the course contents. I mean, for example, if 10 years from now the shift, this 1% which I told today goes up to 10%, and in some countries it's beyond 5% also. It's beyond 5 or little more than that also, some of the European countries. So if it happens in our country also, and it's happening at a very fast pace, and as I also mentioned, we are the largest two-wheeler manufacturer in the world, the market in the world. So at least for the two-wheelers, there would be a need for the government to relook at the design of the course contents, the syllabus, the approvals, etc. So as to prepare for the future. That's very important. Maybe of course, ICE engine as another information which I keep on telling people will continue. I mean, it was mentioned here that oil may last up to 2070, another 45 years from now. So that means what? That means ICE engines will certainly be there. I believe there would be, I can't put a percentage, but they would be there in a very large proportion. But maybe we should also look at changing the course content syllabus also. And this is something which government should initiate. And sorry, I had to intervene,
Sure.
but this was one of the important, but I didn't want to miss.
No, absolutely, Dr. Bhasin. I'll come to you, Dr. Saran. I mean, your experience, of course, you've mentioned that through this whole process of 9 years, sort of working on this concept, working on your products, what's your take on this? How have you seen the quality of manpower that you get? Are they are they still conventionally thinking ICEs, or for you to get students and work with professionals, there has to be some sort of a mindset change that you had to bring in?
So, Dipanshu, it's nice that you asked this. I think, if you look at an EV, there are mechanical components and those remain, right? Brake, tires, wheels, handlebars, suspensions, whatever, right? I mean, so there is, I think that segment of the population will continue to fix those. I think there were very few, if you really look at the roadside workshops or where the large majority of our, workforce works, I was surprised, in any of the auto sector, including in three-wheelers, I think the percentage of people who go back to the dealership to get their vehicle fixed is minuscule after the free service period, right? After the free after the warranty is gone. So I think from that perspective, the larger overwhelming majority of people are the ones who are outside, and in most of these cases, they are ones who are able to fix the run-of-the-mill kind of things, brakes, this, that, whatever needs to be done, denting, painting work, and all that. I think if it comes to tough engine-related things, ECU-related things, then anyway you have to go to a dealership or to a very specialized center. In our case, and more in the EV case, we are realizing that you need to have specialists, electronics and electrical kind of mindset people also. They will start entering this stream. Also software guys. I'm being very honest about it going forward. I do believe, not because I am a computer science graduate, I do believe that software is going to be a huge differentiator for electric vehicles. Different kinds of use cases are going to be built. More and more electric vehicles will allow software customizations to happen, not just by the OEM, but also I think you will start seeing that development over a period of time. I'm not saying that everyone will be able to customize whatever they're doing, but at the same time, it will reach that place. One thing is very important. If you think about, computers, like I say, EVs are computers on wheels. It's not like, when you want to get your computer fixed, it's not like a repairman comes to your shop and starts changing resistors and capacitors. They will typically swap out a board, put in a different board and move on, right? And then they fix that board, whatever happens to it. Similar is going to be the case in EVs. I think it's going to be more boxes that get replaced. There are 5 or 6 or 10, major boxes, and those are the ones that will get replaced. You don't necessarily need to know, as a workshop mechanic, you don't necessarily need to know how a controller is working, as long as you're replacing that controller with an adequate or a similar kind of controller. Were you saying something, Dr. Fulton? Sorry,
No.
Sorry. I think that is where we are seeing more and more of these things happen. So it is a lot mechanical. There will be support systems that will be needed from both the electronic side as well as the software side. I think motors, for example, motors have to be made serviceable. So that is one very important aspect that I do want to mention. As OEMs, as component manufacturers, we have to keep in mind that in our geography, and when I say geography, I mean India and the emerging markets of South Asia, Africa, South America, serviceability is very, very important. You do not throw things away. Our fans are even, rewound, if you think about it in our country, right? You can't imagine throwing away an electric vehicle motor. Not going to happen, right? So you have to ensure serviceability as part of your component manufacturing. How and when that will happen, how soon we will graduate to allowing other people to open our controllers and fix the cards therein, I don't think it's happening anytime soon. But at least at the component level, I am sure more and more workshops are going to talk about. And I notice a lot of education institutions, ITES and all that, we're working closely with a few of these to ensure the upskilling programs that can be initiated and then take the entire lot, whether it is in our production or whether it is in our workshop. So, yeah.
Right. Very, very interesting and very valuable insights on the subject, Dr. Saran. Dr. Fulton, I'm sorry I kept you waiting, but I would like to understand from you, I mean, based on your field of work and across all the various options that we see currently, you did mention a lot about hydrogen, you talked about fuel cells and also synthetic or e-fuels in the future. How do you assess the market, and developments around these? And what are some of the global learnings that you think that developing markets like India can adopt from more mature markets like the US and Europe?
Sure. I also noticed a couple of the questions in the question box were about hydrogen, just sort of what is a hydrogen fuel cell? But I think that there are really interesting different sorts of challenges, whether it's an electric vehicle and a charging infrastructure sort of pathway, not to mention the need for electricity generation that is clean, right? So you have to have that package. With hydrogen, you actually can make it from natural gas. It's not perfect, but it's still a pretty clean fuel. It has carbon emissions, but then you could transition to making it from electricity in a way that actually could offer the electric grid some opportunities, because you can, if you have a lot of renewables in your electric grid, you can make hydrogen when you have excess. You can run your electrolyzers. And so that's an interesting piece for the hydrogen puzzle. The hydrogen vehicles, the fuel cell vehicles, are a very specific technology. And I think that's a big challenge that we don't have very many of them on the road yet. In the United States now, we have about 15,000 fuel cell vehicles, but we have several million electric vehicles. So I see the fuel cell path as very promising in a number of ways, but it's about 5 years or so behind, in terms of development, behind the electric path. But I think we all want to keep it on our radar because of those things I mentioned, but also these are vehicles that you can refuel quickly and that would tend to have a pretty high driving range. And so they're more like a gasoline vehicle in terms of the driving experience and the way you deal with the energy, right, as a consumer. Whereas electric vehicles are really a revolution for people in terms of how they have to think about keeping the vehicle powered up. And we know all the problems associated with trying to find chargers, and if you don't have your own home charger and all that stuff. You wouldn't have that with hydrogen. But on the other hand, you'd need a network of stations that's big enough that you can find fuel when you need it. So it's a whole different set of problems. And then on the liquid fuel side, any of those liquid fuels gives you the opportunity to keep the existing vehicle stock, at least up to some point. As was mentioned, you know, if you go above maybe 15% on ethanol, you need to do something to make it work well for the vehicles. On the biodiesel side, actually with renewable diesel, you can go to 100%. So this is a fully compatible fuel. And if you make it the right way, you can have a low emissions, low carbon fuel that works with today's trucks. So you get those benefits, but you still need a new system to produce the fuel and, you know, move the fuel around. So it's all on the fuel side with some of those alternative fuels, all of the challenges. So you've got really different kinds of challenges in each of these three areas. And, you know, that's all I can kind of say is we need to kind of push ahead everywhere we can, but let's see which ones sort of break through and turn out to be the most successful. And I got to admit, I think right now, in many countries, we're seeing the breakthrough happening with electric vehicles. And I mean, I think Europe it's phenomenal what's happening in Europe in the last 2 years. It's gone from about EU-wide, from about a 5% market share to now it's close to 20. And in some countries like Germany, Sweden, you know, Norway's famous for having a high EV share, but Germany, such a big market, they're up to something like 25% EV market share now. So I think it will happen in Europe in the next 5 years that we'll see this big transition. So once that happens, it'll be interesting to see what role all these other things play. They may not matter so much anymore, at least for cars.
Thank you. Thank you. Gentlemen, at this stage, we are about 10, 12 minutes away from closure of time. I'm going to take some questions from some of our participating delegates. I'll start off with a question from Shashwat Tripathi. I'm sorry. Shashwat Tripathi wants to know how important does the panel see recycling for decarbonization and clean energy important for scope 1 and 2 emission reduction? Okay. So importance of recycling for decarbonization and clean energy. Who would like to take that? Mr. Tyagarajan?
Yeah. See, actually, there is a recent push from the Niti Aayog also when it comes to, for example, the engine oil, which Dr. Bhasin mentioned about. It's something it's, you know, serviced by every vehicle. You just remove the oil and just throw it out, which is there. So there's a push from the government also that can we look at, you know, collecting this oil? Can we reclaim it and again, you know, convert it back to a virgin-based stock so that you have a certain portion of the base oil which uses recycled, you know, from the used oil which is there. So this is something which is also coming up, and I think this is something important we need to do rather than having the oil, you know, just go up and filling the landfill or getting burnt for some other purpose. We can potentially re-refine them and again use it in the mainstream. So I think it's an important topic, and you know, today at least I would say it's in small pockets here and there, some push by the government, some initiative by the oil companies. But as we go forward, I think it's something which is important to be looked at.
Right. Dr. Saran, this question is for you. Soumyabrata does to know, with respect to three-wheelers, last mile mobility vehicles, the local manufacturers use lead acid batteries, which keeps the cost low. Bottom of the pyramid is sensitive and wants localized control of technology. So will these two battery technologies, one new and the other ancient, mentions, will divide the bottom of the pyramid three-wheeler users?
I don't believe so. And I'm saying this from personal experience. So there is a divide, of course, right? If you're using two different kinds of batteries. But I did spend quite a few number of weeks in UP, Bihar, Northern West Bengal, and Orissa, in Sikkim, just trying to understand the e-rickshaw market and how it is coexisting with the, you know, the regular three-wheeler auto market and the larger shared passenger autos, diesel autos. They are coexisting peacefully, right, in these 4 geographies that I visited. The interesting aspect there was that, you know, even in that market, there is you can spot, you know, specific kinds of vehicles that work on the Sukhi battery. And that is an aspiration that most of these guys had to move towards that. I'm talking about e-rickshaws, right? To move to, I think the question is around e-rickshaws because L5 vehicles don't operate on on lead acid batteries. So there is an aspiration already there for people to move to Sukhi batteries. I think it is a matter of cost. And I think a lot of players are now working on the use case for e-rickshaws, because the use case is very different. The load is very well defined and specified. Number of kilometers are well defined and well specified. The gradients and all that are all nicely defined in the e-rickshaw space. They know their limitations and they operate only on those limitations. So for that very specific kind of battery packs, I wouldn't say they are high-end packs. I would not expect them to be able to operate on heavier or other kinds of commercial vehicles. But for their use case, they seem to be doing a good job. Swapping also is something that has been tried in that segment, seems to have created results. So I think Mr. Das is right in saying that there will be a divide, but I think slowly people are realizing that they don't want to work with lead acid batteries. I think there is a push from the government side also, but sooner or later, I think we're getting nicer lithium-ion, cheaper lithium-ion batteries also that will now start filling in that space.
Yeah, I think education and awareness about better quality and better technology would certainly play a role.
They have. Trust me on this. They have that. They know about Sukhi batteries.
Okay. All right. Wonderful. Okay, I'm going to take the next from Atmesh Jain. He wants to know what modifications are required from a calibration point of view to convert conventional engines to flex fuel engines. I'm going to come to you. Anyone who wants to take this? Dr. Fulton, Mr. Tyagarajan?
Doctor, you want to go first?
Well, yeah, you really explained it pretty well, I thought already, but I'll try and then hand it over to you. It depends on the way the vehicle is built in the first place, and there are vehicles being built now, at least in the United States, that are designed to have flex fuel capability up to at least 85% ethanol. But if you don't have that vehicle, then if you want to start from what you would have designed as a regular gasoline vehicle, maybe with 15% capability, you have to make a bunch of changes to the fuel system and sensors and combustion. And I think you showed that pretty well. So it's something that you would have to make a major commitment to as a manufacturer, that you're going to produce certain models that are flex fuel. It's not a minor thing.
Sure.
Yeah, I will add on to this. Let me try to answer it from a different angle. Okay. Suppose going forward, we find a lot of fuel pump outlets are able to dispense E85 fuel, and the government prices it at a very, very attractive pricing. Then the consumers will automatically go for filling the vehicle with E85 fuel. Then for an OEM, knowing that most of the time is going to refuel with E85, it makes sense for us to tune the vehicle, even the hardware, so that we get the best performance with E85. And then we can have a calibration switch at the dashboard, where on occasion, whenever he fills a fuel of E20 or lower blends, he has to just change the switch and we can have a calibration which is suitable for that. So hardware has to be common, of course, since it has to work with both the fuels, but we can go for a calibration which can be optimum for E85 or E20. And of course, the fuel tank will have sometimes a blend of between E20 to E85. So we need to make sure that there's a correction which can happen automatically depending upon the octane available in the fuel. So one is, of course, the technical one. We need to change the complete hardware to make sure it's compatible with the E85 fuel. And then comes the calibration strategy, which could be based on how the fuel availability pans out in the country. We can take advantage of that and accordingly do it.
Right, thank you. Dr. Fulton, there's a question for you. Why is solar energy directly tapped? Why solar energy directly tapped by the vehicle is not being researched vigorously?
Yeah, I saw that. I guess they're thinking about that you could put solar panels right on the car and charge it that way. It's just not enough surface area to capture enough energy to run the car, is the answer. There are some very interesting looking test cars with huge sort of almost wings that have enough solar panels that you can run the car in perfect conditions in the desert and that sort of thing. But No, I think we're going to have to use bigger solar arrays to get that energy and then put it through the electric system to get it to the car, unfortunately. Although rooftop solar, if you have rooftop solar going all day, you can get enough to make a pretty good dent in what the car's charging would be that night. If that's all you're trying to do with the electricity, you could do it.
Right. I'm going to take one final question. Dr. Bhasin, I'm going to come to you. Saurav Srivastava wants to know, knowing that we are at an exploitative stage of finding the right technology and fuel combination that calls for huge investments, tech prowess, and dealing with the uncertainties, isn't it better that a structure with the different OEMs come together under one umbrella and the government machinery guiding the whole initiative?
Yes, pretty good question, very valid also, and that is what I have mentioned in the presentation also. What I call it as the collaborative approach. People not only, I mentioned intra and inter word also at that time I remember, not only 2, 3, 4 manufacturers have to come together and start researching and pulling their resources, but government also has to be pulled in for the ultimate benefit of the customer. So answer is yes, we should do that. Okay.
All right. So gentlemen, a couple of minutes left for closure. What I'm going to do is I'm going to see comments on the subject today. Each one of you about 30 odd seconds. I mean, we've discussed, of course, different alternate fuels, and there are opportunities and options in that we see globally as well as in India. Now, what do you think is the most likely candidate? EVs are a given, EVs we are heading to. But from the other options that we have in the market, what do you think is the most feasible solution for, let's say, a market like India? Let me start with you, Dr. Bhasin.
Not an easy question to answer this, Dipanshu, because they are researchers, there are big companies, there are many senior government people. According to me, good work is being done on EVs, but still lot more has to be done. Whether it will be totally carbon neutral, not a time to discuss now, but I have my doubts. Because on one side, you will not require fossil fuels. On the other side, you will require electricity. We as a country are more dependent on the coal. We produce electricity more from coal. So maybe, it will be, which one will be beneficial, whether it will cover the benefits of leaving the fossils, I do not know. So I'm not very bullish on this, on the longer perspective. But then I also heard Dr. Fulton, and I tend to agree, and I am doing my own studies also on this. I think fuel cell vehicles would be one of the good things to explore for the future.
All right. All right. Mr. Tyagarajan, over to you, your final comments.
Yeah. See, there are two partners in this. One is a consumer. Yeah. For him, cost of ownership is very important. And the ease of refueling, maintaining is very important. And other is the push from the government. So you can have all the push from the government, but if it doesn't meet the customer's cost of ownership, it will never take off, which is there. So if, for example, if you want to take the case of CNG, earlier the CNG was only for the passenger car segment where it was used for Ola, Uber like this. But today, now even the personal segment also, people are happy to buy the CNG because the cost of ownership of petrol or diesel has gone up. So they find CNG is a very attractive option. So as we go forward, maybe we may have EV, we may have hydrogen vehicle. But again, the important thing is the cost of ownership and what the customers comfort with. So both these factors are equally important to decide which way we take it. And taking a long shot now is very, very challenging for any expert. And we need to just wait and watch.
Wonderful, wonderful. Dr. Fulton, your final comments.
Well, I'm going to say that even though you said, we know about EVs, I think it'll come down to if the lithium ion or other new battery technologies keep improving fairly rapidly and keep getting cheaper and, keep providing more range possibility, I think eventually we may see, let's say, road vehicles really go that direction. And I think that could include trucks. But I think trucks are very interesting because it could go battery. It's going to be tough for certain kinds of trucks, very tough, the big heavy ones in the long haul. I agree that fuel cells are a very interesting option. We're beginning to see Europe, China, US, Japan, Korea, all looking very closely at fuel cells. I think India's beginning to. I think that's a really interesting option. And then even more maybe what we call, fringe things, but battery swapping, maybe even in some cases catenary type systems. They're getting looked at for trucks. So I'm going to just say that for trucks, it's kind of wide open, but there's a lot of good possibilities.
Wonderful. For trucks, I guess LNG is another exciting option, isn't it?
Yeah, it's not going to be a zero carbon option, but of course, there's the various liquid fuels that are there. So
right.
I do think there's going to be increasing pressure to make all of these urban vehicles zero emission eventually. So that makes it harder for the liquid fuels. But maybe in India, this is after 2030. I don't know.
Sure. Dr. Saran, your final comments?
Yeah, so I tend to agree. I think the applications are going to drive the technologies that are used in different kinds of vehicles. Lower end of the spectrum, definitely electric. I do believe drivetrains are going to become electric. The source of that energy might be different. So it could be a fuel cell, it could be anything like that, including in long haul. Heavy commercial, today also buses are going around in as full electric because the duty cycles are different. I think long haul will be a very interesting aspect, a very interesting area, like Dr. Fulton said. I think fuel cells will be very interesting in that domain. Don't forget that there is wireless transmission of electricity coming around the corner. It's happening. And when that happens, batteries are out. We have no problem in driving, range anxiety goes out. But whenever that happens, early experiments have started happening within the rooms and all that. And I'm really tracking that. I do believe that is going to change the way we operate as humans if you can transmit electricity wirelessly. But yeah, I'm just an optimist eternally.
Thank you, gentlemen, for being part of this discussion today. I truly appreciate you taking time and sharing your perspectives on the subject. I hope you enjoyed being part of this discussion as much as I enjoyed moderating it. Thank you once again. Appreciate it. Thank you.